Okay, I'm going to go ahead and give a quick little talk about functions, because these are some basic concepts that we're going to keep coming back to throughout this course, and so it's really important that we get a good foundation on the terms. So I wanted to start with just, when we talk about functions, what does that mean? Okay, so the whole basis of functions is that you have some sort of starting value, input value, and then a function is just a rule or a procedure that in some way takes that starting value and figures out and assigns an output value to be paired with it. So the function is just somehow this way, or this procedure, rule, procedure, could be a description maybe. But some way it takes a number, does something to the number to come up with an output that goes with that number. And together you have these pairs of numbers. Okay, so the way we can notate any of those pairings, we're kind of familiar from other classes with your basic ordered pair. So your ordered pair has basically you just write them together with a comma between them, put parentheses around it, and you just have your input number and your output number listed together like that. Okay, other ways that we might have the terminology for this, we're so used to graphing that we tend to think of X and Y as being our standard variables that we tend to use for input and output. Another thing that we might refer to these things as, since you start with your input value and then your output kind of depends on what you started with, we call the output value the dependent value, and it depends on the input value, which in many cases can just be anything. So we call the input value the independent variable, and then the output would be the dependent variable, because the output depends on what you picked over here. And then in general, we call those entire sets of inputs and outputs the domain and range values. So these all kind of are different ways of saying the same idea. You have these pairings of numbers with a function. The thing you see first is the starting value, the input, the domain member, the independent variable's value. You take that value, you run it through some kind of a rule or procedure or description, or you look at a graph, something that tells you what the output value is that is assigned to it. That output value, when we use graphs, it's the Y value. We also call it the dependent value or the range value. Okay, so you can write them as an ordered pair like this, okay, for specific individual pairings. The function notation is another way that you could write it, where if your Y value is the function notation, is the function value. So when you see any language about functions and the function value, we're talking about the Y value of an ordered pair. So the Y value is what we call the function value. So a lot of times you'll see the function notation, they'll say Y, we're going to call this function F, and the input will be X. Okay, so function notation means it looks like this. It doesn't really matter which side the equals is, but you have an input value between the parentheses next to the name of the function, and the number that is set equal to that is your output value. So you'd see f of x equals y. That means if you wanted to get an ordered pair, the number between the parentheses is your input, x, and the number that's equal to the function's value at x would be your output, like this. Okay, so what do these rules look like? You can have something as simple as just literally listing and showing you all of the pairings as an ordered pair like this. Sometimes you might also see it just listed in columns like a table. You'll have your input values on one side and you'll have your output values down the other side, but you can tell if they're on the same row. That's how the pairings go. All of this where they actually show you the numbers that are paired together is called a numeric definition of a function, because we're just showing you the numbers that are paired. So something similar to this is, instead of showing you the numbers, an ordered pair also can represent a point on an XY grid. So they might show you the graphed points. So instead of seeing this, we might say this is the function y equals f of x, and they'll have these 3 points graphed. There's 0, 0. And then I didn't quite leave room, but 2, 6 is way up there somewhere. So this is -1, -3. That point is 0, 0. And this point up here is 2, 6. So they might actually just have individual points drawn. Or if it's a more generalized rule, they might have a whole line or curve that connects all of the XY pairings together. Okay, so that's graphically. Algebraically is when we actually write down a calculation rule between the X and the Y. So in this case, I have picked one where we're going to take the X value and multiply it by 3. So that's one way. You just write an equation that shows the calculation that you do to the input number that creates the output number. So for every one of these, I don't know if you noticed, if I take these individual X values and multiply them by 3, these are the Y values that they create. So we could actually call the output by the letter Y, or we could call the output by this function notation, f of x equals 3 times your input, like that. But this would be a way that you could generalize it beyond just the 3 particular points that were listed. This would be for a whole infinitely many points. You just make up whatever x value you want to, take that number, multiply it by 3, and you've got the rest of that ordered pair. Okay, so verbally is kind of like what you would run into more in a word problem. So you might say the output is 3 times the input value. So that's just, when you're in word problems, you have to kind of go through and pull apart those wordings to try to figure out how you could write an equation out of it if you needed to do some calculating and stuff. Okay, so I wanted to take a minute and just kind of practice. That's the basics. I know there's more if you go and open up and read the text, but I wanted to just go through an exercise that we might do in class. What I've done here is given us a function, and I've decided not to do it like they do it most of the time in the textbook, which is with the algebraic method where you have to do a calculation, but start with a graphical representation of this function. You notice that there's no equation that says y equals 2x cubed and blah, blah, blah. There's no individual points listed. It's just drawn on an XY grid where x is 0, 1, 2, 3, 4, 5, 6, up to 8, and the y values go from 100 up to 150. And they also give us some context for this. So this is actually supposed to be the graph of some average gas bill in a typical year through the winter time. So they've graphed them from December to, well, through the winter and spring, summer to August. And so they've gone through and probably taken a bunch of averages over the years and then just kind of connected them with the smooth curve. So X is what month of the year you're in after December. And then Y is the amount of the gas bill in dollars. You could also, I noticed down here in this problem somewhere later on, they also call this function g of x instead of just y. So you're going to run into problems in your homework. It's really important that you know, I'm going to do a little example up here, how to calculate a function value or to find a function value from looking at a graph. So if I said find g of, let's say, 6, that's how you read it. You say g of 6. What is the function's value with an input of 6? Okay, or I might say, let's do another one. Let's do g of 1, like that. Okay, you're going to run into this all the time in the homework. The number between the parentheses, remember, is our input. We talked about that earlier, input. So we find the x value where it's 6, and then we try to find the y value that goes with it. So you're always going to be reading off a y value when it's asking you for function values. Okay, so g of 6 means x is 6, and my answer is the y value that's paired with an x value of 6. So let's find 6 right here. Now we're going to go find that point on the curve that corresponds to an x value of 6, and then we're going to read off the y value. It looks like about 120. So when x is 6, y is 120. So that's how you fill out a function statement. G of 6 means find the x value of 6, travel straight up or down till you are on the function's graph that has that x value, and then read off the y value for that point. So here's another one just for practice. G of 1 equals, I'm going to be quiet for a second. Let's see if you can look at this picture and see what g of 1 equals. Okay, I'm going to make it where you can see it there. G of 1. G of 1. G of 1. Go refine the graph right there. Read that off. It looks like it's about 145. All right, so G of 1 is about 145. So that's how you read off function values from a graph. The number between the parentheses next to the function's name is input, so you find that on the x-axis, and then you go read the y value that is paired with it. If you were hunting through a big list of ordered pairs, you'd still find the ordered pair that has an x value of 1 and read off the y value that goes with it. Okay, so the rest of this is just kind of talking about looking at the whole thing. When we talk about what time of the year is when gas bills are decreasing each month, anytime we talk about how a function that's graphed like this is increasing or decreasing or changing, of course, we're not talking about a single value. We're talking about a whole section of the graph. So this is as you travel across the graph, as you move through the year, December to January, gas prices are still going up. It looks like it hits its peak gas bill in February, and then it begins to drop a little bit through spring and summer and all the way down. And for some reason in August, the gas bill starts to go up again. Maybe it's so hot that people are taking a bunch of showers and running their hot water. I don't know. But so from this point to this point, it's falling. So that's what decreasing means, is you move from the left to the right. So when they talk about what time of the year, that means for what x values. So we said earlier it peaks at February, which is an x value of 2. And goes and drops until February to August. So in terms of answering the question, is from February to August, right? That's the interval, that time of year. But we want to use the x value notations according to the graph. So February represents an x value of 2. So I'm going to write 2 is where it starts. After 2, it falls until we get to month 8. And then it starts to rise again. All right, so this is called an interval. When you say, where does it start and where does it stop? Well, it starts falling at 2, stops falling at 8, and so we're going to put square brackets around that. There's another section, I'm sure, in the homework that goes into more detail about when you do square brackets versus parentheses. The main difference being you would use a parentheses around the number when it represents the edge of the graph or the function or the interval, but it's not included as part of the graph. And we're going to assume on these smooth curves that those points are included at the very edge of the graph. Okay, so during what time of the year gas bills increasing? Well, it looks like the early part from December up through February. So that's between the x values of 0 to 2, according to this picture. And if we wanted to get picky about it, it looks like from 8 on, but it's really hard to see from 8 to 9, 8 to something or other. So I'm just going to put 8 to... we don't know. So I'll say 8.5, but that's about all we can see. Okay, we wouldn't really need to put the second part. I'm really focusing on that part. But that little bit, it does seem to pick up again. All right, how much is the maximum gas bill? Now, we talked about the outputs are representing the bill and the inputs are representing the month. So when we're talking about a maximum or a minimum function value, again, we're talking about y values. So we're going to find where is the highest y value. That's this right up here. We were talking about this February month. So how much is that bill? That would be reading off the y value, 150. When does this occur? Now this, we actually want to use the context. So we're going to say month 2, but we're going to say February. Because we're dealing, it doesn't say for what x value, it says when does it occur. How much is the minimum? So let's find out where it's the lowest. So maximums and minimums are talking about high points and low points. So this is the low point here. That bill looks like it reads off at about $110. And when does this occur? That's the month of August. So we've got to be good at reading graphs on these problems to be able to do well in this course. So we wanted to do that. And then we're back to this function notation again. It says g of x is going to be the function notation we're going to use for the gas bill amounts. X is supposed to be x month of the year. All right, write a sentence to interpret this function statement. G of 1 equals 145. Okay, now remember we talked about this earlier when we were doing this example, but 1 is your input, so that means month is 1. And 145 is output, that's the bill in dollars. Okay, So month 1 is January. So we want to write these sentences in the context of the units and the descriptions that the X and Y represent. So we'll say in January, the bill was $145. We want to get the units right. The 145 is dollars. The number between the parentheses is representing months. So we listed the month. Okay. So now let's kind of run that backwards and see if we understand it. Now we want to write a statement like this: G of something equals another number. And we're going to use the descriptors to help us pick these two numbers that go here and here. All right, so the gas bill for May was approximately $130. Okay, so again, the number between the parentheses is supposed to be the input. Okay, these are numeric values. So for May, we talked about the inputs are running along here. And so May, we need to find the month of May and then read off the X value. That's the one that's not listed, but it's between 4 and 6. So that would be 5. So May is month 5, which would be your X value. So 5 goes in there. And then what it equals is the output or the Y value. So $130, that's your bill amount. And that's what goes this way. So that's what it's always equal to. So it's $130. You don't have to put the dollar amount on it because this is just numeric context here. All right, so I'm hoping that gets you through a bit of the tricky questions that come up about input and output and domain and range, and specifically how to look at a graph and read off function values. If they say, what is G of 4? We find 4 on the x-axis, and then we find the point that's associated with that point, and we read off the y value, so it looks like it's not quite 140, 138, something like that. So, all right, I'm hoping that helps us with a little bit of what we're trying to do, and so I will get this posted shortly.